Hi, last talk of the day. I'll try to make it short. It's going to be about on-call and how my team at Honeycomb tries to make it human scale. So who here has been on call before? Raise your hand. Oh, that's a lot of people. So I just noticed that it is my 1 year anniversary of being on call this week. So very new to it, and it's still frightening, but it's happening. And also, I just finished being on call last week, so I actually wrote the majority of this talk while on call. It was very inspiring. So hello, my name is Chris. The internet and my mom call me Dai. You might know me as the person on the internet who draws pictures and posts pictures of mountains, but maybe you don't know me at all, which is great. These are some things I like. I like drawing out technical topics. I like crafting a lovely UI. My ideal satisfying afternoon is wrestling a tricky CSS bug. I like being outdoors. I love swimming in the ocean. I love climbing. These are things I don't like as much. I don't like phones. I don't like uncertainty. Don't like being trapped indoors when it's nice outside. So these are kind of all situations that you have to be in while you're on call, unfortunately for me. So how did this happen? How do I cope with being on call? Let me tell you first a little bit about my team. I work at a small startup called Honeycomb. When I say small, there's less than 10 engineers. So a visitor to Honeycomb once told us that we were just like they imagined, except more like pirates. And at first I thought they were talking about our unique fashion sense, but I thought more, and yeah, I guess we're a scrappy group of people that are bonded together by a love for adventure and life on the edge of the unknown technologies. So I guess we're kind of like pirates. This is what our company does. We make an observability product that supports high cardinality data visualization and distributed tracing. Maybe that doesn't mean too much to you yet, but basically, we want to help engineers gain insight to their code while it's running in production because we think this is fundamental to engineers being able to own their code while it's running in production. And a corollary to that is engineers should go on call for their code as it's running in production. And we are, of course, motivated to build a culture of observability that we want to see in the world, in our team. And I guess this is how we're trying to do it. So engineers should be on call. Why? Because when everyone shares the responsibility for maintaining production, then it makes for a more fault-tolerant team. A lot of times, the knowledge of debugging a system is buried in the heads of maybe one or two people who have been there the longest. And that doesn't seem right to me that we're trying to build these fault-tolerant systems, but the single point of failure is a human being. So we need to spread the knowledge all around. But how are we going to do this? We can democratize debugging with the right tools and with a culture of observability in our engineering. So I keep saying this word. What is observability? I see a lot of definitions on the internet, maybe from Wikipedia, but as a practitioner, as an engineer, this is how I see it. Observability is engineers instrumenting their code during development, and second, having access to powerful tools that they can use to visualize their instrumentation in a flexible way. And going more into that, what is instrumentation? So if you know about logs, that is a type of instrumentation. It's some code that is emitting state about your application as it's running, and it takes the unit of events, which are unaggregated structured logs, maybe like a JSON format. So as an example, this event, it has a name, it's a DB call, and it has some other useful context that might be helpful on debugging later, like maybe the user it affects, what host it's on, how long it took. And traces are another form of instrumentation. Traces are basically like events, except they are correlated with each other in parent-child relationships. So I can see which event called another event that results in which event, so I can draw some correlation. And what are tools used to achieve observability? Basically, you need visualization tools that are flexible and collect your raw events and traces and allow you to visualize them in a flexible way. Obviously at Honeycomb, we use Honeycomb, but I'm sure there's other tools that do the job too, whatever you like. And this is how my team does on call. There are 2 rotations. There's a platform rotation full of systems, infrastructure type people. They're primary on call. And there's the product rotation with people who have more of a full stack application background, myself included, and they are secondary on call. And when you're on call, your entire job is to be on call. You don't do roadmap work. You're making improvements to the infrastructure. You're fixing bugs. You're helping with customer requests. That is your job. So when I joined Honeycomb, I knew that they had a culture where every engineer went on call. So I knew this would eventually happen. I'm a front-end engineer from a background, so when I knew that it was going to happen, I felt afraid. I felt like I was about to jump into something kind of uncomfortable and unknown. Production is really intimidating to me. As a front-end engineer, I've not had to think so closely about the consequences of my code in production. I usually, my test will pass, I merge the code, and it will disappear somewhere, presumably to be deployed by a magic process. And now I can no longer ignore this reality of what happens after I merge my code. So if I merge a UI feature that causes users to save bad data, that's an SQL surgery I have to perform. If I cause an issue to affect a small set of users, that's something I need to be able to reproduce. So needless to say, this really changed the way I thought about the development process from before to now as someone who's responsible for my front-end code, innocent front-end code in production. Oh, another caveat is in our on-call setup, the support engineers will escalate the customer tickets to the product on call, and so that would be me. So I started getting a lot of exposure to user feedback, user frustration from support more intimately than I had before, and I thought that was actually really good for my product development process. I felt like it gave me a lot of insight. At first, when I was on call, it was really stressful. All the alerts felt like it was really vying for my attention. I felt like I had to be activated all the time, be around to answer all these questions. But eventually, I found a rhythm. I reached a stride. I learned how to use the tools. I even learned SQL. Felt like it was a big brain stretching journey. As I spent more time around infrastructure people, I started getting some infrastructure literacy. Some of the words they were saying were making sense to me. Some of the graphs they were posting, I recognized them again. So I felt like I was using a little bit of osmosis to really expand the breadth of the stack that I knew. So I was getting more confident. It was going better, and then plot twist. Our company had a situation where we had reduced engineers, and so we had to adapt, and one of the things is we no longer could support 2 on-call rotations, so they had to combine into a new on-call where everyone rotated through primary and secondary, including me. Everyone had to be responsible for all the systems, infrastructure, everything. That was... Yeah, I really felt very intimidated when I heard that because, okay, so maybe I'm very confident with front end. I can do browsers, do UIs, and maybe our applications back end. I know a little bit now. I know a little bit about databases, but when I think, okay, what about all these nodes of this custom database that we're running because we wrote a custom database even though you're not supposed to? What if I get paged by that? So I felt like basically full stack went from a full stack to all the way to infrastructure, and I felt like I was looking at this chasm, and I'm like, oh, I guess I'm responsible for this now. Whew. Okay, so what are some ways that we have to cope with this situation? I think the most important is to try to think of ways we can democratize debugging. And what I mean by that is make systems debugging more accessible to any level of engineer. Maybe they don't speak infrastructure, but they can look at instrumentation. So step one, the basics, give the engineers a production first aid kit. And these are some of the things in our production first aid kit. We use feature flags, which is a way to configure what features to show users depending on some complicated set of configurations that's external to the application. So basically, you can change the configuration without doing a deploy. And this is really nifty when, and also we have instrumented our services to include feature flag information with every event. And so sometimes it becomes the case that we realize, the issue right here is directly correlated to the feature flag, which we can see through our instrumentation. So what we can do here is we can turn off this problematic feature simply by configuring the feature flag. No deploy is necessary. And I love it when I get to resolve a bug this way because it's so easy. And this is one way to make on-call a little bit more accessible for people. Just like no need to really need your hands into production by SSHing. It's like feature flags, if you have something experimental, make it easy to turn off. If you think something might go wrong, consider feature flagging it. Other ways to democratize debugging that might be a little bit less obvious than maybe making scripts is to externalize the debugging strategies from the brains of your most experienced teammates and make it more accessible to everyone. And when I talk about instrumentation, this means that your senior teammates are using their instrumentation to express what is important, what are the important context clues in the code, in the system. So this is an example of a graph that I generated after getting an alert that there was really long, unusually long latency for one of these cron jobs that we have, one of our services. And one thing that is really nice about our build system is that we have automatically added any deploy window to our data. So when I generated this graph, I immediately saw, okay, the deploy window is the problem area, the really high latency event is within the deploy window. So I correlate those two immediately. Maybe that's an instinct that a senior engineer has, but for me, like when I see that I get a page or alert, I don't know really where to go first. And so as much information as possible that's been provided by the instrumentation, it helps me make these correlations. And it just helps my debugging process. It helps me gives me something to latch onto and start with. Oh, yes. Another way to more intentionally externalize debugging strategies from senior engineers is to pair program with them. And I suppose I can't exactly call it programming because when systems debugging, there's a lot of terminals going around. And I actually find it fascinating that terminals are so private. You can learn good coding practice by reading other people's code, by reviewing PRs, getting your PRs reviewed. But I don't see other people so clearly, like how they debug their systems through their terminal. It's not so public. And so I try to take these opportunities when I get maybe a low-level alert to try to grab one of these other engineers and like work with them. And whenever I shoulder serve someone doing things in their terminal, I feel like I always learn some new trick, and people always have something to tell me. So I think this is like the direct way to transfer knowledge. It's still pretty underrated. We actually have a number of remote employees and people who are semi-remote. So sometimes it takes a little bit extra, to ask, hey, can you share your screen? But I think it's an instinct that it's really worth building. Oh, this is a photo of me pair programming with one of my favorite colleagues. She can't type, so I usually take the keyboard. Another thing that a way to transfer knowledge. So in Honeycomb, I don't know if this is available in other cases, but there's a recorded history of how what graphs people have made. And what I like to do when I'm joining a new project or looking at a new part of the system is I want to see like what other graphs people are generating in that area, and it gives me an idea of how to work with data, like what kind of questions people tend to ask, what instrumentation exists, just to get a lay of the land. And so while I was writing this talk, I just pulled up the latest graphs from that just happened at the time when I was making the talk, and I saw this really interesting graph. It appears to be a graph of the durations, like how long that builds have been taking throughout the last year, and you can see that it's been subtly increasing throughout the year. And first of all, this is great. I learned something new. I didn't know that we were that what was instrumented. That's pretty neat. And also, I feel so validated because I'm always complaining, the build's so slow. And as you can, I'm like, yeah, well, it is actually, the data shows it's getting slower. I'm right to complain. And also, I noticed my manager was looking at this, so like, does this mean we're going to soon have time to make our builds faster? Maybe. Just learn a lot from just this one graph. Another thing I saw while just idly glancing through history, so I recently joined a new team. The service is called Dalmatian. All our services are named after dogs. And I saw in this graph that my colleague was looking at a breakdown by host, and clearly this jumped out at me. One of the hosts was acting really erratically. What's going on there? I don't know. I poked into it a little bit, but I couldn't figure out. Just I'm really new to this project, so I figured, the next time I see my teammate, I might ask him, like, so what's up with that? And maybe I'll learn something he wouldn't have otherwise thought to share with me. Yeah, I feel like just snooping on what other people are doing, I just learn a ton. And this is a trace from the same service that we saw in the last graph. And what I really like about tracing views is I feel like it gives you a different way to visualize what is going on within your service, like how all the calls relate to each other, how the services relate to each other. I feel like it gives me an idea of what's going on in the system without necessarily going in and reading through the code. Sometimes it gives me high-level enough information that I can try to triage a bug to a certain area and hand it off to someone else. So I feel like this is a really powerful tool for people who just are a little bit new to the system. So I feel like what this all brings together is all these tools and methods of sharing knowledge and sharing processes is engineering culture where curiosity is encouraged, and it's really enabled by the powerful tooling and by having the instrumentation be part of the development process. I've been on some teams where admitting that I don't know something is a sign of weakness, but I feel like on this team, it's really encouraged. Senior engineers are seen being confused in public, and they're asking questions, and they're engaging each other in these conversations, and kind of digging through data together. And I find this collaborative, curious spirit, like, it's very good for the team. I feel like I learn a lot when I follow along with these conversations, and I just feel safe to ask questions. And I think that when you're in the position of being on call, feeling safe to ask questions is pretty vital to success. Other aspects of our engineering culture, we have blameless postmortems, but I think even more important is that they're very learning focused. Like, people are curious, okay, what went wrong? Let's get to the bottom of this. And again, like, along with our instrumentation, like our strong culture of instrumentation, like, we're just really trying to focus, like, what is going on? And like always trying to dig a little deeper in the data. I feel like before I really had this instrumentation step, thinking about context in my head, like all these systems, I haven't read the code. I don't know too much about distributed systems yet. It's kind of a black hole of mystery horror to me, but I feel like with these tools, it gives me a lens to look inside them from the outside with data, and that gives me some comfort. And I definitely feel like I write, maybe not better, but different code from a different tactic now that I have more of a feel of looking at my code in production, looking at other people's code in production, how they set themselves up for success by instrumenting. So when something goes wrong, they can look at the data. So about me being very anxious to go on call for our entire system, I think the result is it's manageable once you know the ropes, when you have the proper equipment, and you're set up for success. I wouldn't say it's easy. I won't say I always love it, but I think it's manageable, and I feel like I just learn a lot. I just have come to realize that complex systems, they're basically always in a state of broken. And the more powerful your tools are, the more cracks and seams you can see, the more imperfections and the more problems. And then the issue becomes being experienced enough to identify, okay, here's a problem. It's on fire. It needs to be fixed now. I need to go pull people in. Or can it wait until tomorrow? Or can it wait until the next week? I feel like that's the next level that I'm still getting there. I'm still getting my feel for it. But I've learned that being on call, it's solving the problem. That's not my job. My job is to ensure the problem is acknowledged and prioritized, and someone knows about it. And I feel like just having that context, I'm doing my job right, and that's the best I can do. And I am done with this talk. Thank you.